In this video, we are going to discuss about important concept of data science, which is feature transformation. And within this module, we are going to discuss two topics. The first topic is normalization and the second one is standardization. Many machine learning algorithms perform better when numerical inputs variables are scaled to a standard range. And this include algorithms that uses weighted sum of inputs, algorithm like linear regression, and algorithms that uses distance matrix like k-nearest neighbor algorithms. The two most popular techniques for scaling numerical data prior to modeling or prior to applying machine learning algorithms are normalization and standardization. Now within feature transformation, we are going to discuss these two topics. And first of all, let us start with normalization. And after performing these techniques about normalization, we will go to standardization. So let us start with normalization. So normalization scales each input variable separately to the range 0 to 1. Now this range is different for normalization and standardization. Since we are discussing about the normalization, so each of the input will be changed to this range value 0 to 1. And this range is for the floating point values where we have the most precision. Whereas the topic standardization scales each input variable separately by subtracting the mean. Mean here means a center and dividing it by a standard deviation. So let us discuss first the concept of normalization. So for concept of normalization, I'm going to give a simple example here. So let us say I have this data. So this is my column, let's say. So this is X, that is independent variable. And I have this data like 10, 20, 30, 5, 7 and so on. So at this moment, maybe we can take this much example only. So within X, I have 5 data. Now I'm going to apply the concept of feature transformation. So we already discussed what is the importance of feature transformation. So using feature transformation, our algorithms will perform better. Now let us so first of all, let us understand what is the feature transformation means. Then we are going to do it practically in the upcoming videos. So this is my data. From this data, can you check what is the maximum value of X? So I have a maximum value of X that is 30. All other numbers are less than 30, so that is a maximum. And from this data, can you identify the minimum values? So the minimum values is 5. So first of all, you start with identifying maximum and minimum value within your column. Now, in order to apply the concept of normalization, we take the value X that needs to be normalized. Let's say this is the normalized value for X, and our formula is take that X which needs to be normalized, subtract with the minimum value of this entire column and divide it by max minus min. So this is our formula to apply the normalization. Now let us say I want to normalize the value 10. So for that, what I can do is I'll just give the value of X as 10. So give the value X as 10 and subtract it with the minimum. And what is the minimum here? Minimum is 5. And divide it by max minus min. So max minus min here is 30 minus 5. Now you calculate this value, and anything you calculate will be in the range 0 to 1. It can be anything, but it will be within 0 to 1. So you can also calculate directly. So it will be 5 at the top, and here you will have 25. So 5 divided by 5 is 25. So you will get 1 by 5. And what is the value of 1 by 5? It is 0.2. So this is the value, and you can see this value is within the range of 0 to 1. So each of these value will be converted now 0 to 1 values range. So you can take for the 20 now. So instead of x, you put 20 and do the same for the next data point and so on. So x minus minimum is 5 divided by max minus mean. So this way you convert all these values into the range that is 0 to 1. Now what is the advantage of doing this? The advantage of doing this is that the larger number, if it is used as it is, then our model or algorithm will be biased toward this larger number. So we don't want that. Rather, we want all these value to be treated equally by the machine learning model. So that is the reason we want all of these values to be within SORP 10 standard scale. So we convert all these values within the range of 0 to 1, so that it will be in the same scale, and our machine learning model won't be the bias toward the greater value. Rather, it will treat all these values equally. So that is the reason we create this feature transformation technique to convert any input data into the format that is of standard range. Many machine learning algorithms perform better when numerical input variables are scaled to standard range. So this is the reason we have to convert them into some standard range. Machine learning model learns a mapping from input variable to output variable. So that means machine learning model is just a function that takes input and it converts that input into the output. As such, the scale and distribution of the data drawn from the domain may be different for each variables. For example, let us say that you are making a model where you are taking the salary of a person, and taking the salary you are going to predict whether that person will buy a home or not. So this is your model. Now in the salary you might find the difference in the salary between different person. A middle, that is a middle person, or maybe middle salary person, will have some value that will be about median value. Let's say he earns 50k annually, and there will be some people that are rich people who earns maybe more than $1 million, maybe $5 million annually. So you can see there is certain discrepancies within the salary column. Some people are earning less, maybe some are earning only 10k per year. So you can clearly see there is a difference within the salary. Now if you use this data without performing the feature transformation, then our model or the algorithm will be biased toward the higher value. Our algorithm tend to neglect the lesser values, and we don't want that. Our model should be created in a way that all those values should be treated equally. Our model should not be biased. So that is the reason we need to perform a concept called as feature transformation. Similarly, our input variables may have different scale or different unit. Maybe some are measured in feet, some are measured in kilometers, and some are in the hours. Different values. That in turn may mean that variable have different scales. Now, in these differences in scale across input variables may increase the difficulty of the problem being modeled. An example of this is that large input values, that is a spread of hundred or thousands of data, let's say, can result in a model that learns large weight values. So that means, I have already told you this, our model will be biased toward large weight values. A model with a large weight values is often unstable also, meaning that it may suffer from poor performance during learning and sensitive to input values, resulting in higher generalization error. So that means, if you do not make your input into the standard scale, then we can have higher generalization error, which means our model won't be able to generalize through input data. Rather, we have the high error. Our model won't be that accurate. So that is the reason we take the input, we need to scale it into some standard scale so that our model won't be biased toward the large value. Rather, our model will treat all the values equally.